All right, let's do some problem together right here. So make sure you're on track. Okay. So question 1, what do we use to measure strength of interaction between particles? What quantity or what do we use? Boiling point or melting point? So we look at the melting point or boiling point. Either a compound or a substance has high boiling point or melting point, which means that the interaction between them is really strong. Okay. The state of matter adopts the shape and volume of its container. Has no shape, has no volume. Gotta rely on container. Gas fly away. So all right, let's take a look right here. So solid, definite shape, definite volume. Right. So like an ice, you know its shape, you know its volume. Liquid, still no volume, but the shape is assumed by the container. Okay. So adopt. Sorry, I said wrong. Adopt the shape of the container, but have definite volume still. Gas, no shape, no volume. Right? If you have container, the gas expand to occupy the whole container. Okay, there's no volume for sure. Right? And no shape either. It's just shape gonna look just like the container. All right. Which of the following is or are malleable? So malleable, that's the property of what type of compound? Ionic compound, covalent compound, or metallic compound? Metallic compound. So basically, I asked you which one is metallic compound. Right? Potassium chloride, that's ionic compound. Chlorine gas is a covalent compound. Zinc, yes. Right? Water is covalent compound with a hydrogen bond. Carbon, we haven't talked about this, but carbon by itself it's totally not ionic compound or not metallic compound. Gold by itself, so that's a metallic compound. Okay, so these two are malleable. All right, next one, the strongest intermolecular force in each of the what am I doing here? So find the strongest intermolecular forces in each of the following molecule. Okay, so carbon dioxide, we haven't learned it yet. So, but carbon dioxide is non-polar, so not hydrogen bond, not dipole-dipole. It's not an ionic compound, not a metallic compound. So no ionic bond, no metallic bond. Right? The interaction between a carbon dioxide is London forces. We'll learn it later in a bit. All right, next one. Look at the difference in electronegativity. So this is a totally covalent compound, right? Not ionic, not metallic. This is a covalent compound. Now, it's either ionic, hydrogen bond or dipole-dipole. Okay. So let's take a look at the difference in electronegativity between these bonds. So I'm sure you know oxygen and hydrogen. There's a big difference in electronegativity. All right. So this guy came from hydrogen bond right there. So oxygen will go by with the hydrogen of another atom, hydrogen will go attracts oxygen from another molecule. Okay, CCl, that's the opposite, not real opposite. So not ionic compound, not metallic compound for sure. So this guy is a covalent compound, and your option is going to be hydrogen bond or dipole-dipole. All right, and CCl, that's totally have some different in electronegativity. Not as much as an O and H, right? But because of this slightly different in electronegativity, so it allows it to form dipole-dipole interaction. Chlorine got paired with carbon, carbon will pair with chlorine of another molecule. Okay? All right, let's go to the next video.